Welcome. Thank you for joining us today. I'm Amy Sam. I am the Health Education Project Specialist at the Maxwell and Eleanor Blum Patient Family Learning Center at Mass General.
Hi, my name is Angel. I'm a public health student and I'm currently interning here at the Blum Center.
Today's program is part of our Lifestyle Medicine and Cancer series, a special collaboration between the Blum Center and Lifestyle Medicine program at Mass General Cancer Center. Before it gets started, I just want to go a few items with you all. Please note that today's session is being recorded for educational purposes. If you're interested in viewing the recording, it'll be made available on the Blum Center website at massgeneral.org/Blum-Center. Please note that you're in listen-only mode. Everyone has muted so you can hear our guest speakers today. If you have any questions for our guest speakers, you may use the chat feature, which is located at the bottom of your screen. We'll have time for them in the end. Only Blum Center staff and our guest speakers will see your questions. Please do not share any personal medical information or questions in the chat. If you have a personal medical question, please ask your doctor. Lastly, at the end of today's session, you'll be directed to a brief survey, which we'd like to ask you to help us complete. Your feedback is important to us as you plan future programs. All right, so next I'm going to turn it over to Angel, who will introduce today's guest speakers.
Thank you, Amy. Joining us today are Carol Sullivan and Ashley Draviam. Carol is a registered dietitian with more than 20 years of experience practicing as a certified specialist in oncology nutrition at MGH. She has a special interest in lifestyle medicine where she serves as a lead dietitian at the Mass Cancer Center Lifestyle Medicine Program, where she offers individual and virtual group visits. The program is offered to patients on the survivorship continuum, incorporating the pillars of lifestyle medicine, which include eating healthfully, being physically active, managing stress, getting adequate sleep, and having a strong support system. Ashley Draviam is a senior clinical dietitian and board-certified specialist in oncology nutrition. She has been at MGH for over 10 years, working with adult and pediatric patients to provide individualized medical nutrition therapy. Ashley is also part of the Mass General Cancer Center Lifestyle Medicine Program, where she helps patients and survivors incorporate healthy behaviors into their lifestyles. Ashley is certified as a qualified bilingual staff in Spanish and enjoys connecting with patients and families from all backgrounds to help with nutrition through their oncology journey. They are here today to give a talk on the gut microbiome and what it means for cancer. Please join us in welcoming Carol and Ashley.
Thank you so much, Angel, for that fabulous introduction. I'm going to share my screen so we can get to the slides. Can everyone see it? Good? Okay. So Carol and I are so excited to be here with you all today, talking about this really exciting, interesting, complicated topic on the gut microbiome and cancer. We did a quick PubMed as we were researching a PubMed search and found that about almost 30,000 studies a year are being published on the gut microbiome. So there's just an explosion of research in this area. In particular, related to cancer, there have been nearly 3,000 studies on the gut microbiome and cancer in the last few years. And despite this large amount of research, this area of research is really still in its infancy. And there's so much that we are learning all the time. It's a really exciting time for this. So we're going to just share some of the research with you. We'll start off by talking about what the gut microbiome is and the role that it plays in the body. And then we'll share just a small fraction of the research that we've picked out to highlight the gut microbiome's role in cancer prevention, progression, and treatment. And then I'm going to turn it over to Carol to talk about gut microbiome diversity and kind of the practical part about how does diet actually impact our gut microbiome and what can we do on this front to impact health. She'll talk about fiber, fermented foods, probiotics, omega-3s, and a few other topics. So let's dive into what is the gut microbiome. The gut microbiome is a community of organisms. We think mostly about bacteria, but it also includes fungi, viruses, and other microbes that live in the digestive tract, mainly in the intestines. And these microbes help with a variety of functions and processes in our body. In the gut in particular, they help with digesting food, especially fiber, which Carol's going to talk a lot about later. They help produce important vitamins like B vitamins and vitamin K. They help protect against harmful bacteria, so keeping those harmful bacteria out and keeping our whole gut microbiome healthy. And then this is really interesting. So we used to think of the gut microbiome as kind of just those bacteria and those living organisms in our gut. And now we know that there's a really important role of the compounds that these bacteria produce. So they're these byproducts, metabolites that are beneficial. Short chain fatty acids is a common one. Butyrate is one that we will be talking about. These are produced by fiber fermentation by the good bacteria in the gut. And while the bacteria mostly stays, hopefully, in our gut, these metabolites are able to cross the gut barrier into the bloodstream and move around the body. So many people have heard of the gut-brain axis, and this is one of the ways in which we know that the gut and our brain can communicate. These bugs and their metabolites impact, as I mentioned, many functions in our body, systemically, inflammation, immune function, insulin sensitivity and blood glucose control, hunger and appetite, mood, metabolism, and much more. Carol found this cartoon, which I love because it just illustrates so well this connection between the gut microbiome and other systems in our body. So we see this little gut bacteria here talking on the phone to an immune cell saying, hey guys, we've got a situation here, incoming rotavirus, a bad pathogen. And the immune cell says, no problem, which troops do you need? So just that crosstalk that we're learning more about how these different systems in our bodies communicate with each other. Now, dysbiosis is an imbalance in this microbiome, the collection of microorganisms in our gut. We can see on the right here a normal gut microbiome is rich in bifidobacteria and lactobacilli, looks all happy. And then on the right side, there's the dysbiosis. So fewer lactobacilli and bifidobacteria, and then a variety of these other more harmful bacteria types. We aren't going to talk a lot about individual bacteria because what we focus on is the health benefits of the bacteria rather than the individual strains. We just don't know enough about individual strains to make any sort of recommendations or know specifically what altering one type of bacteria can do. What we focus on and what the research mostly focuses on is what are the health benefits of these and how do we create diversity and balance to promote health. Dysbiosis can be caused by a variety of factors. Diet, antibiotics, and infection are a few that have significant effects on the gut microbiome. And it can result in changes and negative changes throughout our bodies. We'll be focusing specifically today on the growth and invasion of pathogenic or disease-causing species and cancer. So how does the gut microbiome impact cancer? The theory is that dysbiosis in our gut can lead to inflammation, excess inflammation that increases cancer risk. Chronic inflammation in a part of the body increases the chance that normal cells become cancerous by altering the DNA. And we see over here on the right, colon cancer and intestinal cancer on the top. There's lots of research being done in this area because, of course, that's the area where the gut microbiome is housed in our intestinal tract. But again, because we know that these metabolites can move throughout the body, there's an impact on other types of cancer, breast cancer, stomach, lung, melanoma, multiple myeloma, which is a blood cancer. And we'll talk about some of those various cancers. On the bright side, though, we also know that a healthy gut microbiome can be preventative against cancer. So that's where we ultimately want to take this research and all this information is to figure out how do we improve our gut microbiome to be protective against cancer and improve our overall health. So it's a really, really exciting area of research. The gut microbiome and cancer prevention. This study that I'm going to talk about is related to colorectal cancer. And we know that colon and colorectal cancer is the third most common cancer worldwide, and it's strongly impacted by diet. So previous research has shown that meat-based diets increases risk for colorectal cancer, whereas pesca-vegetarian, so fish and vegetables diet, decreases the risk for colorectal cancer. And this is compared to a standard diet. So think of the typical American diet. And what the researchers in this study did is they used germ-free rats. They have no gut bacteria, so they're bred to be basically a clean slate. And they gave them fecal transplants. So they implanted the feces and all of the gut microbiota in the feces from rats fed either a pesca-vegetarian diet or a meat-based diet. What they saw was that rats who were given the meat-based diet bacteria developed more early signs of colon cancer, whereas the rats given the pesca-vegetarian diet were more protected from colon cancer, showing that gut bacteria shaped by diet can cause or prevent colon cancer. A lot of these studies are done in animals, and we know the ideal studies are done in humans, but of course it would be unethical to give humans a diet that we know might cause cancer. So there is a fair amount of research, epidemiological, which is population-based research or observational research in humans, showing that an increased intake of red and processed meats is associated with colon and colorectal cancer. And so basically, this research in animals just corroborates that and gives us a more detailed picture of what's happening in humans. In breast cancer, the gut microbiome can affect development through different mechanisms. Some of these mechanisms are similar in other cancers as well, like modulation of the immune system. In breast cancer in particular, the gut microbiome can alter estrogen levels, which of course can impact breast cancer cell growth. And then there's also the production of the bacterial metabolites, which I mentioned, which affect tumor cells and the tumor microenvironment and can impact the development and progression of cancer. With these specific bacteria, they're in estrogen receptor positive breast cancer. They saw when there was an increased abundance of the genus Salmonus, that was associated with an increased risk of developing this type of cancer, while more of the genus Adler-Creutzia was protective against this type of cancer. And with HER2 positive breast cancer, an increased abundance of the genus Ruminococcus 2 was associated with a decreased risk, where the genus Erysipelatotoclostridium, difficult words to pronounce, was associated with an increased risk of cancer. I know I said we weren't going to be talking a lot about the specific types, but what this does is it just shows us that there's a strong association between the types of gut bacteria that we have and cancer risk. Now on to cancer progression. This study was done in multiple myeloma, and the image over here on the right looks very complicated unless you're a biochemist, but I want you to just look over on the right side and see that it's starting from the bacteria that's up in our gut, impacts different factors in our body, all the way down to the bone marrow microenvironment and can impact multiple myeloma progression. So multiple myeloma is a blood cancer. And we know that dysbiosis in our gut reduces the production of short-chain fatty acids. So remember, these are the metabolites, the byproducts of fiber fermentation from the bacteria in our gut. And these short-chain fatty acids are really beneficial in a lot of ways. They help to protect the integrity of our gut lining, the strength of our gut, and reduce inflammation. And short-chain fatty acids can also suppress tumor growth by turning down or blocking pathways that produce inflammation. We know from various studies that high levels of inflammatory markers in multiple myeloma bone marrow tumor environment can contribute to multiple myeloma progression. So this is just showing that the dysbiosis, which lowers those short chain fatty acid levels, can increase inflammation through these pathways and lead to the progression of multiple myeloma. This study is really cool because it was done in humans, which is always ideal, and it's talking about food. So as dietitians, this is what we like to see because it gives us a sense of how we can take tangible action from this research. MGUS, or monoclonal gammopathy of undetermined significance, and SMM, smoldering multiple myeloma, are considered benign conditions. MGUS, the blood contains an abnormal protein called M protein. And these are precancerous, but they can develop into more significant conditions like multiple myeloma. So in this study, participants followed a 12-week plant-based meal plan. They were provided 2 meals a day plus nutrition education. Not surprisingly, they increased their intake of plant foods, but significantly from 20 to 92% during the intervention. And what they found was an increased diversity and abundance of that butyrate-producing bacteria, that good bacteria that produces those short-chain fatty acids, which, as we've talked about, is beneficial for gut health. They also saw an increase in anti-inflammatory immune cells and a decrease in blood markers of inflammation. Also, not surprisingly, they did see weight loss, which often happens on a plant-based meal plan. But particularly interesting was 2 patients whose BMI dropped significantly, 13 and 19%. And they saw an improvement in their M protein levels, which you remember is a marker of progression. So this is really cool because it shows, even though this is a very small population, it shows that a high fiber plant-based diet, even just for 12 weeks, may delay or prevent progression from MGUS or SMM to multiple myeloma. And this, of course, is the goal, right? Is to figure out how to prevent a disease from turning into cancer. And because of these promising results, they're building on this with a Nutrivention 3 trial where they're enrolling more patients to further investigate the impact of a plant-based diet with or without supplements on progression. In melanoma, skin cancer, this group of researchers studied the gut melanoma patients on immunotherapy. It's an increasingly common type of therapy for cancer treatment. And as the name implies, it involves the immune system and harnessing our own immune system to try to target and get rid of cancer cells. And since we know that the gut microbiome and the immune system are so closely linked, the goal here ultimately would be to try to figure out how we can impact the gut microbiome to improve the effectiveness of this type of treatment. In the first study, the researchers found that patients who responded well to treatment had different and more diverse gut bacteria compared to the patients who did not respond. And the responders' gut microbiome profiles were also linked to stronger immune responses. And then they took the gut bacteria from these responders and did fecal transplants into these germ-free mice. Remember, these are the ones who don't have any bacteria in them already. And what they found was that the mice who had been infused with the gut bacteria from the responders showed improved anti-tumor immunity, showing that gut bacteria may impact a patient's response to treatment with immunotherapy. And then building on this, the same group wanted to look at how diet and probiotic supplements would impact immunotherapy outcomes. So they looked at patients and found that those who ate more than 20 grams of fiber, and importantly, who avoided probiotic supplements, had better outcomes on immunotherapy. And for every extra 5 grams of fiber per day that these patients ate, was associated with a 30% lower risk of cancer progression or death. And this is really, really cool because this is something that we can act on. 5 grams of fiber. Kara will talk about how to actually get this, but this is a change that we can make with a really significant impact on cancer risk. Concluding that a high fiber diet may be protective against cancer. Chemotherapy, another main treatment pathway for cancer that has a lot of side effects. So there's some research looking into interventions that may be able to modulate or alter the gut microbiome to try to improve the effectiveness and tolerance of chemotherapy. And what we now know is that the bacteria in your gut can influence how well chemotherapy works. These are just a few examples. This Fusobacterium nucleatum, which is a harmful gut bacteria, can help cancer cells resist chemotherapy, which of course we want to avoid any resistance to chemotherapy. Whereas this Akkermansia municidifila, which is a good bacterium, has been shown to improve chemotherapy response in mice. We also know that the beneficial metabolites like the short-chain fatty acids I've talked about and this UDCA can improve chemotherapy results as well. With regards to tolerance, that's something we're always thinking about because we want to make sure that patients can get the full dose and the full course of treatment that's prescribed. And we're learning that the gut bacteria and their metabolites can reduce harmful side effects from chemotherapy, for example, mouth sores. Bifidobacterium longum in particular helps lower inflammation and improve gut health, which can make chemotherapy side effects less severe. And in one study in mice, this Bifidobacterium longum plus selenium helped with common chemotherapy symptoms like weight loss and diarrhea. And lastly, pancreatic cancer. Pancreatic cancer is a difficult cancer to treat because it's characterized by dense tissue around the tumor that makes it hard for the chemotherapy to get in and access and kill the cancer cells. So in this study, mice were given butyrate, that short-chain fatty acid, and then were given gemcitabine chemotherapy, which is a common chemotherapy for pancreatic cancer. And what was found was that the mice who were given butyrate had a reduced amount of the harmful or dense tissue around tumors that makes the cancer harder to treat. The butyrate also helped protect the intestinal lining from damage from chemotherapy, which can significantly decrease side effects, and also improve the gut microbiome by increasing the overall amounts of beneficial bacteria and reducing harmful bacteria linked to inflammation. So that's just a brief summary, a tidbit of the research that we have. And now I'm going to pass it over to Carol to talk about some of the practical applications and dietary interventions that we can intervene on based on this research.
Thanks, Ashley, for covering some of the heavy lifting when it comes to this research. I am going to talk about a little bit of research, but more specifically when it comes to food, which there actually isn't a lot of food-based research on the gut microbiome related to cancer. There's not much at all, but it's still important to think about how can we actually improve our gut microbiome diversity, because those are the connections we can make between the gut microbiome and decreasing inflammation. So Ash, you can take it to the next slide. So I just want to take care of what I think are some key terms when we're actually talking about food and how to change our gut microbiome diversity. The first one being prebiotics, which prebiotics are the actual food that these beneficial bacteria will be eating. To have a healthy gut microbiome, you have to feed the probiotic bacteria well. Probiotics are the actual live microorganisms that confer a health benefit to us, to the host. Postbiotics are a newer term, and postbiotics are really the byproducts of probiotics. So they could be the metabolites like the short-chain fatty acids that Ashley's mentioned. It could be the actual dead bugs that might be conferring a health benefit. So this is another newer area of research when it comes to this biotic world. Next slide. Just to note that fiber isn't just, it's one title that has a lot of terms underneath it. We're going to talk about a couple of a few forms of fiber. So fiber in general is a type of carbohydrate found in plants that the body cannot digest. Starting with soluble fiber actually dissolves in water and creates this gel-like substance. If you've ever mashed a banana or overcooked oatmeal, you'll see that gel form. And this helps lower cholesterol and blood sugar and promotes feelings of fullness. So these are things like oats, barley, beans, lentils, peas, bananas, apples, potatoes, and sweet potatoes. And then insoluble fiber does not dissolve in water. Water just rolls right off of it. This is most of our fruits and vegetables. And this type of fiber adds bulk to our stool, helps promote regular bowel movements, and really helps prevent constipation. And this is in things like wheat bran, vegetables, whole grains, nuts, and seeds. Finally, the prebiotic fiber, which we care about for this presentation, is what actually feeds the good gut microbes. The good gut microbes will eat these fibers for food. And all prebiotics are fiber, but not all fiber is prebiotic or, feeding these good microbes. It's cool that prebiotic fibers also help with some calcium and magnesium absorption. And really, there's about like 8 sources of this type of fiber. We're not going to go through all of them. And prebiotic fiber includes garlic and onions, bananas, Jerusalem artichokes, soybeans, asparagus, wheat, and whole grain products. And there's more too. Flaxseed is also a prebiotic fiber. Next slide, Ash. So I think this is important to kind of refer back to what Ashley was saying, that one melanoma study where they saw patients who were eating a greater than 20-gram fiber diet on immunotherapy actually had better outcomes. The average American eats about 16 grams of fiber a day. So that would be considered low fiber. And compared to the recommended daily allowance, the recommendation is 14 grams of fiber per 1,000 calories that you need. On top of that, there's good research in areas like heart health, where we know that 25 to 30 grams of fiber is really ideal for cardiovascular health. So I've put on here, what does 25 to 30 grams of fiber look like? Because that should be really what people are shooting for when it comes to their daily fiber intake. And you can see here, the very top of the list are beans and lentils, where 1 cup of lentils is 15 grams of fiber. A cup of beans generally is 12 to 15 grams of fiber. And then all of the fruits and vegetables per cup per serving have at least 3 or 4 grams of fiber. And then further down the list, you can see chia seeds and flax seeds have anywhere from like 3 grams of fiber per tablespoon to up to 6 to 10. This next slide, go ahead, is one of the studies that we actually have on food and colorectal cancer survivors, where the participants were adults with a history of colorectal cancer or high-risk precancerous polyps. And these patients were counseled by a dietitian to consume 1 cup of canned pressure-cooked white navy beans for 8 weeks. And they compared this group to the control, which were participants that maintained their regular diet without any added beans. And they assessed the stool and fasting blood samples of these patients every 4 weeks to evaluate changes to their gut microbiome. And they found that the gut microbiome diversity increased, and they increased the beneficial bacteria that can help with these reductions of inflammation and the improved immune regulation. An important point here is that the positive effects actually diminished after participants stopped eating the beans, really emphasizing the need for our diet habits to be consistent. As far as tolerance goes, there weren't any serious side effects, but some people definitely had an aversion to this daily bean intake at some point, especially after 8 weeks. The bottom line here is that incorporating a cup of beans a day to the daily diet of these cancer survivors enhanced the gut microbiome diversity and regulated immune and inflammatory processes. And consistent consumption is really the key to reaping these benefits. I love this slide, just showing gut microbiome diversity in a photo or in a cartoon. So we know that reduced diversity results in really important species that maintain equilibrium, and reducing diversity leads to dysbiosis. So another way that we can support diversity is trying to eat 30 different plant foods per week. So this is research from the American Gut Project, which is one of the largest citizen science microbiome studies to date. And I love this cartoon because it really demonstrates what we're trying to do here. We have this one microbe on the left eating his pepperoni pizza with a white crust compared to this table of robust gut microbes. There's a lot of them. They're happy and they're flourishing, eating a variety of plants from nuts and grains and fruit and veggies and legumes and seeds. So I love that image. So how do you actually get close to that 30 plant foods? So one way that I like to think about this in my own house is, instead of preparing a tray of broccoli, could I instead either roast way more than just one vegetable? That's one way to do it. Or you could make a broccoli slaw where you have broccoli, carrots, cabbage, almonds, maybe there's some garlic and onion in the dressing. You can easily, adding raisins, you can easily get a broccoli slaw up to like 6 different plant foods just at one meal. Next slide. Now we're going to switch gears to fermented foods, which we know help to improve gut microbiome diversity. And this is from a study where they actually compared a group of people eating a high fiber diet versus a fermented food diet, where there was a 4-week ramp up period where people were counseled to eat more fermented foods or fiber in their diet. And then there was a 6-week maintenance period. The fiber group here doubled their fiber intake from 20 grams to 45 grams. The fermented food group increased their intake of fermented foods from a half serving a day to 3 to 6 servings per day. And the researchers found that a diet rich in the diverse fermented foods, which we're going to talk about what those are in a minute, increased their microbiome diversity and decreased inflammatory markers. We're seeing a pattern here, right? And then surprisingly, the high fiber group increased the density of their microbes, but they didn't actually have an increase in diversity. And the researchers note that this could have been due to the small sample size, that it was a brief intervention, and that maybe they needed to be more specific about the types of fiber that they were encouraging. So encouraging those prebiotic fibers to specifically feed the good bacteria might have been more beneficial. Next slide. So what do we recommend? So we recommend trying to experiment with some of these foods, which they definitely have very interesting flavor profiles if you're not used to eating fermented foods. So yogurt tends to be one of the more popular fermented foods. If you enjoy yogurt, or if you're at least lukewarm on yogurt, maybe trying something like kefir that has a higher diversity of bugs than yogurt does, just to keep changing things up. And then trying sauerkraut. So trying sauerkraut on a sandwich and just a small amount instead of lettuce. Adding kimchi. Kimchi is usually traditionally added to like rice and noodle and meat dishes, but you could try adding kimchi to eggs, for example, can be pretty good. And just trying small bites of these things can be helpful, because there can be a tolerance issue too. Miso is great as a miso soup. You may be familiar with it as a soup, but miso can actually be used to make some pretty tasty salad dressings. So there's lots of ways that you can think about incorporating fermented foods into the diet. So another really important point here is that these foods need to be consumed regularly for benefits. So these microbes that we're eating from the fermented foods don't colonize in us long term. They still might have beneficial effects if we are consuming them consistently and like continuously giving ourselves those bugs, those microbes. Next slide. So to address that study where the high fiber diet group didn't actually have increased diversity, there is some research showing that if we're combining fermented foods with prebiotic foods, we can actually help feed those beneficial microbes. So the recommendation is to pair some of those fermented foods, which some of those fermented foods already have things like garlic and onion, but pairing even in your day or at the same meal with garlic, onion, bananas, Jerusalem artichokes, soybeans, asparagus, wheat and whole grain products like cereals and breads. So trying to take it up a notch and think about what you're actually pairing with your fermented foods. And this label on the right here, I thought was worth sharing because we do want to caution against having kefir that has too much added sugar. So this is the plain version, and you'll see with the total added sugars in the label, it is 0 from the added sugars. And I also like in the ingredient list that's listed way on the bottom here on the right-hand corner, you can see the probiotic cultures are listed, which there are many compared to maybe like the 1, 2, or 3 that might be in a yogurt. Next slide, Ash. So next, I'm going to answer, I think, some of the questions that have already come up in the chat about probiotic supplements in cancer. So the first concern here is that probiotic supplements, not already in food, but as a supplement, may pose a risk of infection in immunocompromised patients, including those undergoing certain cancer treatments. So if you are taking a probiotic supplement and undergoing treatment, definitely let your team know that you're taking it. The second thing is that probiotics may actually blunt the effectiveness of immunotherapy by reducing the gut microbiome diversity. This is a callback to the melanoma study that Ashley mentioned in the beginning, where patients who ate more fiber and avoided probiotic supplements actually had better outcomes. The third listed here is more of a concern for your wallet, where we know that there's been good research showing that probiotic supplements do not actually increase gut microbiome diversity in healthy people. So I think a lot of people are taking these supplements with the intention of improving their health, and that really might not be the case. So bottom line here, avoid self-prescribed probiotics, especially on immunotherapy, and really focus on diet-based microbial support. Here is our other section, a few things that we thought were worth including, which the first one is vitamin D. Living in New England, this is the sunshine vitamin, and a lot of us are at higher risk for vitamin D deficiency. If you have been through cancer treatment, you may also be at higher risk for bone disease, and vitamin D is really important for healthy bones. So vitamin D helps the immune system work properly and lowers inflammation, and high vitamin D levels, high or appropriate vitamin D levels are associated with increased levels of beneficial species of bacteria and lower levels of pathogenic bacteria. So how much do we need? Your blood levels should be greater than 30 nanograms per milliliter. And this is what is considered adequate by the Endocrine Society to support calcium absorption, bone strength, and prevent fracture. And the recommended amount that we need is 1,500 to 2,000 IU daily for adults, which there aren't a ton of foods that are high in vitamin D, which this can be one that if you meet with a dietitian, they may recommend that you take a supplement based on your diet and your blood levels. Next slide. I love that polyphenols are beneficial to our gut health because polyphenols are substances that are found in plants and give some flowers, fruits, vegetables, their colors, and polyphenols also have a lot of antioxidant activity. And as dietitians, we love to give fruits and vegetables and plant foods bigger reason to eat them. So love these. This is also cool that polyphenols are really poorly absorbed in the small intestine. About 90% of polyphenols reach the colon, where they serve as food for gut bacteria, boosting these beneficial bacteria, suppressing pathogenic bacteria, and enhancing the production of all of those really great metabolites that have the anti-inflammatory properties. And then also strengthening the gut barrier and reducing inflammation. So foods that are high in polyphenols, these are just some of them, include plums, cherries, grapes, berries, pomegranate, cocoa or dark chocolate, coffee, and black tea. And the American Institute for Cancer Research really recommends 3 servings a day minimum of fruits and vegetables just for cancer prevention and prevention of recurrence. So this really is in line with our normal recommendations. Next slide. The next one is omega-3 fatty acids, which offer a lot of health benefits and turns out are also good for the gut microbiome. You'll see, again, more overlap that omega-3s boost the populations of beneficial bacteria and are linked to anti-inflammatory effects, improved gut barrier integrity, and metabolic health. And something specific with the omega-3s, they have been shown to decrease levels of lipopolysaccharide or LPS producing bacteria, which are really pro-inflammatory. So we love omega-3s here in the Cancer Center and prefer that people try to get them from food like fatty fish, like salmon, sardines, and mackerel. If you're not a huge fan of fatty fish, it's pretty easy to start sprinkling ground flaxseed and chia seed into things like oatmeal, cereals on top of peanut butter toast. You can even put some ground flaxseed in the middle of a peanut butter and jelly sandwich for your kids. It doesn't really taste like that much. Walnuts are also another great high omega-3 plant-based food with lots of places that they can be added as well. Next slide. So what may negatively impact the gut microbiome? I'm not going to go over each one of these individually, but this kind of is the list. Like, what should I avoid if I want to improve my gut microbiome health? And alcohol, saturated fat, red meat, ultra-processed food diet that's low in fiber, and then some sweeteners might negatively impact the diversity of the gut microbiome, including sucralose, saccharin, and ACE-K. Next slide. So I think we did a great job on time here, Ash. So the summary here is that the gut microbiome, including the microbes, as well as all of those awesome metabolites, are really intricately linked with cancer development, progression, and even treatment outcomes. And while there is potential to use the gut microbiome as a target for cancer prevention and treatment, the research really is too new to develop precision treatment options based on specific microbes or even patterns of bugs. The bottom line really here is that the gut microbiome influences cancer in some pretty complicated ways, and we're really like at surface level when it comes to the research. Everyone's gut microbiome is different, and we don't really know what an ideal microbiome is that will positively impact cancer or overall health. But we do know that eating more fiber, increasing the number of plant foods that you eat over the week, and eating fermented foods daily can really increase the diversity of your gut microbiome, positively impacting overall health. So those are the big takeaways from today. We definitely have time for some questions.
Thank you so much, Ashley and Carol. We are now at the end of the session. If you have any questions, feel free to enter them in chat. We do have many wonderful questions, so we're going to try our best to get through them in the next 15 minutes. We have a question regarding the gut microbiome. How much of it is it genetic?
Ooh.
That is a great question. And I don't know that we could say like a percent of it that is genetic. I think some portion of it certainly is genetic. We know even from the moment that you come out of the birth canal that the mother's microbiome is, and some of those bacteria are being transferred to the baby. And that's kind of like the beginning of them developing their own microbiome. But yeah, I don't know, if there's really a way to test how much of that is genetic.
I would agree with Ashley. I was going to say the same thing about birth and younger years, we know that has a big impact on gut microbiome, and we know we can change our gut microbiome with food. So, despite there being some piece that could be genetic, we know that we can do things to change it.
Thank you. As we age and get older, how much can our diet affect our gut microbiome and cancer prevention?
Yeah, a lot. I mean, it can continue to impact your gut microbiome, yeah, for, the whole of your life, really. Our gut microbiome, there's some research showing that it can change as quickly as one day. So one day of eating something different can impact your gut microbiome. It's not going to drastically overhaul it, but there is evidence that kind of, that phrase, you are what you eat, is a little more true than we thought. So I think that shows that, it's not, it doesn't take years to change your gut microbiome. And so this would be true even, as we age, the effects would still be the same.
Thank you. Can estrogen increase one's risk of developing breast cancer? If so, then why is cancer more prevalent in older women who have lower estrogen levels due to menopause?
This one is going to be for our oncologists. We are going to answer some food-related questions. Sorry.
And I know there were a bunch of questions. You addressed them, Kara, earlier on about probiotics, but in case we had some folks who joined late, can you summarize your thoughts on use of probiotics?
Yeah, so the jury's still out on probiotics. I mean, we, to start with, know that if you're otherwise healthy, taking a probiotic probably doesn't do anything for your gut microbiome diversity. And then if you are on immunotherapy, taking a probiotic might not give you as good as an outcome compared to just having a high fiber diet. And then the other concern was if you are immunocompromised, taking a probiotic could be a concern. So making sure that you check with your team if you're taking a probiotic and you're currently on treatment and you're not sure if you're immunocompromised.
I'll add one thing to that, which is that when you look at a probiotic bottle, maybe there's one type of bacteria, or maybe they're even up to 30, say. But because everyone's gut microbiome is different, we don't know, I could need something different to slightly enhance my gut microbiome than Carol or than Angel or Amy or any of you out there, right? And we don't know what's ideal and how to alter that. And because there's a symbiotic relationship where these gut bacteria kind of act together and their metabolites act together, it's much more complicated than adding, just the amount or the types of bacteria that you can get in a probiotic. There are some newer tests that are kind of evaluating individuals' gut microbiomes and giving you a breakdown. But I think we're really not at the point yet where we know how to act on that to make real tangible recommendations for what people need from that.
And this is also an area where probiotic supplements are ahead of the actual research, right? Like if you look at most of the probiotic supplements on the market, they are lactobacillus and bifidobacterium that are like easy and inexpensive to grow and manufacture. And yeah, I think there's a lot of selling going on too.
Thank you. We have a few nutrition-related questions. When you're talking about meat-based diets, does that include chicken, eggs, and turkey, or just red meats?
Yeah, that includes, so in that study, that included meat, including chicken and turkey, as opposed to just fish and a vegetarian diet. When we talk about the research in humans showing an association or a link between colon cancer and red or processed meat, that's more specifically talking about red meat, so like beef and lamb and then processed meats, which are things like bacon, sausage, ham, deli meats, smoked meats, and smoked fishes.
Thank you. And we have a follow-up question regarding that study. You mentioned fiber. Can you clarify whether specifically soluble or insoluble fiber?
Yeah, the soluble or insoluble, probably, I mean, that study was really just talking about total fiber. The study that saw an improvement in outcomes for melanoma in people on immunotherapy, they were just looking at total fiber. There wasn't any differentiation between the type, not even prebiotic fiber. But the prebiotic fiber is probably helpful to include. Yeah.
I think one interesting thing about fiber too is we talk about the types soluble and insoluble, but in fact, most foods have a combination of both. So when we're saying foods that are high in soluble fiber, like the oats or the bananas, those foods that absorb the water or liquid, those also probably have some insoluble fiber in them. It's just that they're predominantly soluble fiber and vice versa. So something like beans and lentils are very high in both types of fiber. So I think that just comes back to that variety in our diet. That's why the diversity and the quantity of different types of plant foods is important, because then we're getting more different types and balances of fiber.
Good point.
Couple of questions on fiber. Does daily juice containing kale, cucumbers, green apples, and parsley make a difference, or is fiber extracted not providing nutritional benefits?
We want the fiber. Yeah, eat that sounds good. You could make that into a salad.
And
Less work, maybe.
how about artichokes? What part of the artichoke has fiber? The leaves, the heart?
Yeah, the heart has that prebiotic fiber. That's great for the gut microbes. There's so many ways you can include artichokes. I love mine on like a homemade pizza. So good.
And
That's an example though of, sorry, the balance of fibers, because there is probably the leaves have more of that insoluble fiber, right? An apple's another great example. The flesh of the apple is that soluble fiber, but the skin is the insoluble fiber.
But in terms of like gut health, it might not matter if it's soluble or insoluble.
Right.
And does the fiber content change when cooked?
Can make it easier to digest when you're cooking fiber. You are going to be breaking down some of the plant cell wall if you are chopping and if you are cooking, but there is still plenty of fiber intact, and it can just make digestion easier if you're cooking fiber down.
Thank you. And what are your thoughts on soybean milk, and tofu?
Go for
We
it.
love them.
Love soy. Yep.
Yeah. We get this question a lot from a lot of our patients who are concerned about soy based on some really old research that was not done in humans. We now know that soy provides so many benefits from an anti-cancer perspective, and those whole soy foods that you mentioned, like soy milk and tofu, soybeans like edamame, are really easy to incorporate into your diet and can provide protein and fiber and cancer fighting nutrients and omega-3s. So yeah, we always talk about ways to incorporate more soy products into people's diets.
Yeah, that's a great example. There's people, I think, commenting that they can't eat fiber because of IBS, but it's actually not totally true. There's plenty of fiber options. You just have to meet with somebody that knows what fiber options would be best tolerated and do some experimenting. And soy milk and plant milks are one way to get in some more of those nutrients. There's definitely ways to fit some of these foods into your diet, even if you have IBS or can't tolerate a high fiber diet.
And to your point earlier about the juices and the cooking, those questions, breaking those down, like making a smoothie rather than juicing. You're getting the fiber, but you're breaking that down into that more easily digestible way where even people with gastrointestinal issues like IBS can tolerate a lot of those types of fibers a lot better. So some of it is in the preparation too.
And the quantity, right? That's something else that is interesting in this research. If you're starting with a smaller amount of beans a day, let's say, and you're slowly increasing up to that cup, your body responds by actually making more of those enzymes to break down that type of carbohydrate that can otherwise give you some gas and bloating. So there's definitely strategies to get more of those things in.
Thank you. We have a question on coffee and teas. How do they affect our gut microbiome?
They have good polyphenols, which get to your colon and feed your good microbes. So we like coffee and tea as long as caffeine is not interrupting sleep. We usually say stop drinking any caffeine after noon, even if you don't think that you're sensitive, because caffeine, there is a metabolite that interferes with melatonin that can impact sleep no matter what. And then being careful of what you're adding to your coffee or tea, right? Like trying to minimize added sugar, creams, and things like that.
Thank you. If we are eating well to support our gut health and then eat poorly, how long does it usually take to get back into balance? Is there another way? Sorry. Another way is how quickly will our gut change if we don't eat well?
Yeah, I think that's going to vary person to person, but I mentioned before that there's some research showing that your gut can alter within a day to a certain degree. So I think it's, the exciting thing is that it's pretty malleable. Like there's a lot that we can do here to improve our gut microbiome and pretty quickly. It's when we think about promoting health, a lot of the things that we're focusing on and recommending can take some time, right? And this is actually one of those things where we can get almost more of a quicker fix. So, life happens. Everyone's going to have times where they're, not eating as well as maybe their normal diet, and that's okay. But trying to, get back and resume a good, healthy, high fiber, plant-based, diverse diet is going to get your gut microbiome back on track probably pretty quickly.
I think we have time for one more question. What are your thoughts on the FODMAP diet?
Helpful, but in its entirety, to eliminate all of the different foods as an elimination diet, sometimes for specific people can be helpful, but the more current recommendations are to experiment with certain carbohydrates as part of that low FODMAP diet and eliminate specific groups one at a time instead of eliminating all, 4 to 6 groups of carbohydrate. It can be very restrictive. So I think it can be helpful to figure out what you might be foods you might be negatively responding to, but the idea is to minimize the elimination of any foods and to make sure that you're adding things back in that you actually tolerate well. So, low FODMAP diet. Like if someone just hands you a diet to follow and says follow low FODMAP diet, go find someone that knows how to explain the low FODMAP diet.
Plug for dietitians.
Thank you so much. We did receive a number of questions regarding today's recording. It will be made available on the Blum Center website. I entered that in the chat. It's www.massgeneral.org/Blum-Center. I would give it about 2 to 3 weeks for it to become available, but it will be through there. Simply scroll down to the section titled Past Blum Center Programs, and then there's this rectangular button that says View All Programs on YouTube, and that should take you to the recording. Sorry if we couldn't get to all of the questions. These are all great questions. For any questions that we weren't able to address, feel free to have that discussion with your care team. Carol, Ashley, thank you so much for joining us today. This was all excellent.
Thanks
Thank
so
you,
much for
everyone.
having us.
Take
Bye.
care, everyone.